Good morning, everyone, and thank you for joining us at our webinar this morning. So, this is Celeste Miranda. I am the publisher of Terpenes and Testing magazine and the CEO of Mace Media Group. Today, we are going to be putting on a webinar about Delta 8. And in order to do that, I summoned one of my very good friends, and he never ceases to amaze me. And Dr. John Mckay has been in our space for quite some time. He's a wealth of information, as most of you out there know, and he has done a lot of research, a lot of it right in front of me, and I had to endure this about Delta 8. There's so many questions, and here at Mace Media Group with Terpenes and Testing and Extraction Magazine and CBD Health and Wellness Magazine, and we're putting on a future Delta 8 conference. We get so many questions about it. We have so many of our advertisers and our exhibitors and people like that in the space, but then we also get those calls saying, can't believe you guys are involved with Delta 8. That's horrible, blah, blah, blah. So, there's so much controversy around it. Is it good? Is it bad? Is it, what's going to happen? Is it a trend? Where's it going to shoot off to? I mean, it's the whole thing is so interesting. And so John is going to come on and talk a little bit about it. He's going to talk about the good and the bad and where he thinks this is going in the future, near and far. And so just real quick, a little bit about Dr. John Mckay. He did the majority of his time and with a successful parole at Waters. And I believe it was something like 29 years where he was the Senior Director of Strategic Technologies. He did receive his PhD from the University of Vermont, and he has been our scientific editor for Terpenes and Testing magazine as well as Extraction magazine for many years now. He is currently the founder of Synergistic Technologies Associates. And you'll see him in a lot of places, especially through my group. As I said, we think the world of him and his knowledge. He'll be keynoting as well one day of ours at our concentration conference this year in Tulsa, Oklahoma. So without further ado, I will welcome on to you, and we will get started with this webinar. Dr. John Mckay. But first, let me tell you, you can put any questions you have in the Q&A section of this webinar. My staff will be on the back end the entire time. We will keep those questions in order. He probably won't answer them during the presentation. The presentation is live, but we will ask him those questions at the end of the presentation, which will probably be about an hour. So remember, put any questions in the Q&A. Try not to put them in the chat, although we'll see him there too. And we'll ask him the questions when he's done. So Mr. Dr. John Mckay, if you would please turn on your camera and we'll get this going.
Oh, good. I think everyone can see me now. I have to be able to successfully share my screen, correct?
That is correct, and we can see you.
Okay.
Sounds like someone's at your door.
It does. They keep on knocking, but they can't come in.
Okay, we see your screen. Go. Thanks.
Thank you very much. So what I'd like to do is speak today about Delta 8 specifically and some of the other cannabinoids. And I call it a walk in the woods. And it's like, what's going to happen? Would it happen? And all the other different types of things that are possible within this application space. So some of the things that I look at when I'm reviewing and looking at technology is where's the basis of it coming from? And I think over the last year, we have had an opportunity to see science in conflict with people. So now you have a social science and you have a physical science, and then a lot of people within the human race have a bias towards what they believe, and that's typically now set together with facts and how you want to see those facts. So within this, I decided to have an opportunity to talk about Delta 8, but talk about Delta 8 with two fictional characters. So my name is John. So I picked two characters on the boundaries of the continuum of Delta 8. The pro-Delta 8, Jan, and the anti-Delta 8, Ian. Though I might try to do voices, it's probably less entertaining for you than it is for me. Within those parts of the concept, there's people within a continuum always of looking at it's either this or it's that, and the black and white. And I think somewhere in the middle is reality. We'll also look at what is Delta 8, the chemical itself, where it comes from, what it does within the plant. I have a who says, which is my clever way of saying World Health Organization and what they're doing, what's known about the compound, and a quick summary. So what is the future? When I'm looking at these two compounds here and the way they're numbered as a chemistry on this side, they can be numbered a number of different ways, but we'll choose this one at this time. And you can see that the carbons, those are those places where everything connects in, the number 1, 2, 3, 4, and that's on the phenyl side. Then you have the other ones on the other ring up in the top that are by the red letters, and you can see 9, 10, 10A, 6A, 7, and 8. Probably would have been better if I'd gone numerical at first, so we'll start with that. On the right-hand side, you see between 9 and 10 a double line. That's called a double bond. It means that you have more electrons running around between those two carbons. And you see the other one between 8 and 9. And so within 8 and 9, you can see that's called Delta 8, and the one on the right is called Delta 9. We typically talk about THC because at that point in time when we were just talking THC, most of the people were only talking about Delta 9, so by default they just called it THC. The THC has a lot of isomers, and we'll look at those later, but looking at this one here, you can see that the double bond, the two double lines, are over on the 8 and the 9, and that's why it's called Delta 8. So between these two molecules, it's in a flat two-dimensional structure. That's not how the molecule actually looks. It is in 3 dimensions, and you're trying to see that 3 dimensions through 2 dimensions. And that's why you see that hydrogen that's over by the 10A with a dotted line. That means it's going into the paper. The one on the left-hand side, the H, with the solid line, means that it's coming out at you. So now you have to be able to see that those two compounds are there. The Delta 8 and the Delta 9, they will have a different form, a different fit. And those different fits means they're going into the body or into anything, and it has a little bit different conformation. It looks a little bit different. So we'll look at what that is and see what the future of these are. So these are the current, I would say the current prominent members of the THC family. They have the surname of THC and a different front name. In a typical workflow for natural products, allows you to see an enormous amount of compounds that would be in a natural plant, and then seeing a smaller number after you've done, for example, a very simple extraction. It doesn't matter what the extraction type is. You're actually looking at the basis for, hold on. Sorry, I had to answer the door. You're looking for the basis of what the plant looks like. So For that, you're seeing taking out the stalks and stem would be easy one. You would then move through less compounds that are available through the process and having less peaks. And then finally, as you're moving towards something that's totally pure, you would be able to see just one component. So as we're looking at the purification process, and we're looking at talking about delta 8, delta 9, delta 10, delta 10A, 6A, what we're really looking for is we're looking for how do we have the least number of compounds that we're putting into a formulation. So one of the things that I like to look at is experimenting with what's the current knowledge of CBD, THC, and delta 8. An experiment that's an amusing for me to try and do, and that is asking people today, have you heard of CBD? And most people have heard of the letters. They'll typically tell you what they've tried. They'll typically tell you what their experience is. They'll typically tell you if someone else has tried it or they know of someone else. And each one of them is going to have an opinion based on that. And there's other things that we have in our society already that people have an opinion on. But trying this one is of great interest. And as you're hearing those answers and you know more about it, then you're going to find that they have different experiences and different facets of what they believe. The next question would be, what have you heard about delta 8? Because once you move through something that's more sensitive to them, more understandable, now you move to delta 8 and following up with the questions. And following with, have you ever heard of any other cannabis products? And so a lot of people are using delta 8, but dropping off the surname. There's not a lot of people talking about delta 9 and dropping out the surname. They typically talk about THC. So why are we having this discussion about delta 8? Typically, when I've asked people about that for what we're having for a presentation, some of the common reasons are there's an interest in the compound. I mean, what does it do? Where does it fit into the body? How do you get a hold of it? Where does it come from in the plant? How does it differ from the other cannabinoids, whether structurally or through biochemistry? And how is it affected by the current regulations? How would I market the product if I did have some? And then also looking for supporting evidence or reasons to have or not use it. Excuse me a moment. So I'm not going to talk about regulations. I'm a chemist, and lawyers are lawyers and chemists are chemists, and we took different courses during our university and high school, and we had different interests. And so I'm going to stay out of that. I will answer some opinion questions, but I really don't want to focus on as much the regulations, though we can talk about those. So everyone has a different experience and everyone's coming from a different size. So having a seminar that may amuse some of you, may frustrate others is something I'm just going to have to deal with. So Ian, on the left-hand side, believes delta 8 should not be legal like CBD, because remembering this is coming from the hemp farm bill. And so part of this is started from that capability and some of the wording that came from the farm bill. And then we have Jan. He believes delta 8 should be legal like CBD. So on those two sides, you see that one man, they're the same people, and I got them off of the Microsoft website that allows me to do this. And so my name is John, now you have Ian and you have Jan. And that's how I'd like to position the presentation. Number one is there's a lot of compounds, well over 500 compounds that have been identified. This is some of the earlier work by Slade and Asoli. And we can see the number of compounds that are done. And what I've done is I've taken the first page of this paper, and I've taken the constituents by chemical class on the right-hand side, and then I've blown up the middle in the middle to talk about the different cannabinoids and the 70 known constituents at that time. So when you look at all of those, you can see that there's a significant number of delta 9. So it's not just one delta 9. There's 9 known isomers, and delta 8. There's two known isomers of trans, delta 8 THC, as well as the fact of all the other molecules below, CBN, CBE, CBL. And when this paper was first put out, way back in 2005, no one was looking at all those other cannabinoids, and they were there. So it's not as though any of these were unknown. So when people feel like they discovered, delta 8, that's like discovering California. It was there beforehand. So when you look at that, delta 8 is identified as some of the other plants. One of the arguments that Ian or Jan would say is that all the other, it's there with the other degradation products. So CBN is not, in quotes, a natural product made by a synthase in the cannabinoid, in the cannabis plant. So the plants that are, the compounds that are made come from the synthases, CBGA, and then you have THCA synthase making THCA. THC, if you were to look at it as talking about details, you would say that that was a degradation product because you've taken off the carboxylic acid group, which came from the molecule itself. So CBN and delta 8 would be similar if you were to just call them degradation products like CBN. Delta 8 is as much identified in the plant as THC and has the same surname. So Ian, on the other side, has decided that this is the same data that can be used to show that delta 8 is like delta 9. It has the same surname. CBN does not have the surname. So based on that, saying that they came from the same family, he's purporting that that's exactly why it should not be used. So telling the boys to settle down, getting a little ahead of ourselves, and you can already tell that these two are fairly opinionated. Let's look at the cannabis plant and start from the beginning on what we talk about as a plant and what we talk about as far as, what we've called in the human race has decided to identify these plants as. They're both cannabis plants, and one has less than 0.3 THC to be able to be generated to have plants that have high CBD but low THC. So we've taken the plant and tried to make it so that we have all those not having the THC. Making this up as I go along, that's like a seedless watermelon plant, for example. The watermelon plant with the seeds would be like THC. So now we have something that has a high THC, we have a mixed THC to CBD and a high CBD, but still above the 0.3% THC. So within that product line, we've taken two different species and now trying to grow them so that they selectively don't have a compound. On Ian's side, Ian sees this as ammunition. If it quacks like a duck and walks like a duck, it's a kind of duck, not a dog. He's really saying that this has the same obvious choices of it's a THC, and so it still has the same surname. That is why delta 8 is just another way to sell delta 9 analogs to people in states that don't have delta 9. That's Ian's approach. And by the way, Jan, I think your CBD is a dog in many ways. Nothing's been proven about this. It's just another snake oil. So you have that type of facet of looking at the same data. Jan has a different opinion. I'm only wanting the compounds that are derived from hemp. Why would I want to make delta 8 from a THC plant? And he does have some points there, because the delta 9 isn't having any trouble being made by a plant in 13 weeks. And there's a lot of different varieties which allow you to have medicine made from delta 9 that has different terpene mixtures in it, which gives different attributes to a different disease state or well-being that you're wanting. And he thinks, because he's taking a bit of verse to Ian taking an attack at him, and he says, by the way, I think you're barking up the wrong tree. That goes to the dog. And CBD has demonstrated potential therapeutic value, but I agree we need strong regulations to protect consumer safety, reduce fraudulent claims, including self-regulation, until there's more federal regulations. And I will say that so many people have done a great job out there with the major companies really working into self-regulation, self-regulating themselves into GMP, self-regulating themselves into standards that are far higher than anyone is expecting or having them to do. Others are not doing that. And so that's where sometimes you can get that feeling of concession. Well, let's look at the chemistry, the plant chemistry. So number one, I don't know plant chemistry. I just know compounds that go from one to the other. Where they come from and how they come from and all the other details is, the same reason what I don't know so much about biology and what happens in the brain in great detail. I can understand it like I can understand reading a law book from John Grissom, but that doesn't mean that that makes me a lawyer. Let's look at CBGA. So CBGA can be decarboxylated. As you can see, that group can fall off. You can see it circled around the THCA. And then you have CBDA synthase, you have THCA synthase, and you also have CBCA synthase. But I'm just looking at the CBD and the CBDA and the THCA. When those are seen in heat, and you'll see that in a crop, then you will have some decarboxylation. If they're sitting in the sun, there is some obvious decarboxylation because it's an oxidation of air, it's time, it's what happened. You also see through that you can have CBNA, which means I've degraded that one ring. Remember the one ring that we talked up on the right hand side? Well, now it has all 6 carbons together. So when you look at that, that's the key. When you do the decarboxylation of the THC, it can go to CBN. So when you're talking about CBN, as Ian did, and seeing that it is a natural degradation plant, a natural degradation product of the plant in a significant yield in some cases, 2-3%, and it has been used in some of the formulations and postulated for therapeutic value, you can see where they have the different possibilities. And you also have oxidation. So you see the CO2 going away, that's where it goes off. You have oxidative degradation right down to the CBN. And there's many different academic peer-reviewed papers that demonstrate that, as well as how it goes through that process, as well as synthetic processes to get to the same product. This, of course, brings you on into the fact that a major pathway to CBN, no one's having trouble, no one talks about CBN, and it's just another degradation product that can happen through the plant, and why it should be legal. Ian holds a different perspective. He believes that the major pathway to CBN is through delta 8, and he must remind him that it has the same surname. Now, through that process, it means it can be a stepwise through, and so therefore it can be synthesized, or it can be stopped in the regulations so that it goes not directly to CBN. There's a number of different pathways to get to that product. Just like there's a number of different pathways, I'm making this up as I go along, which is scary for anyone who knows me, is that the subway system in New York City, for example, it has a lot of different ways that you can get to a different part of the city. And so those are the parts that are most important. So when you look at that and you see, Ian back on a roll, there's hardly any difference between the compounds, unless you want to play duck, duck, goose again, Jan. He's still driving towards the fact. You're trying to avoid the facts. So more people are making money selling to a drug in states that THC is not legal. So when you're on that side of the continuum, on the back, I don't know which ways, I guess I put them on the left and right, so it doesn't really matter. But when you're on that side of the boundary and you have nothing in between, then that's a position that you can take. And so now justifying what happens. Jan, on the other side, still believes a different compound, and entirely, it's got a different aspect on the metabolism, the body. He cites different studies where the bioavailability and bioactivity are different. And there is such a thing as a KI, where you look at the activity of a compound in the body at half the concentration, and you look at the other studies that have been done that show some of the different aspects of the compound. And you can see that they are different. They are different because they're going to fall into a protein that's different. They're going to have different effects and different longevity and cite other proteins that are possible. Well, let's look at the other part of that. Who cares? That's the World Health Organization. That's my pun for the day. Methods and ease of illicit manufacturing. So if you look at the World Health Organization on the right side, the WHO Expert Committee on the Drug Dependence Critical Reviews, the isomers of THC. So they've looked at all the isomers of THC, and so this is one of the things, I'm just citing the one that we're talking about with Delta 8, though they did cite other ones. So minus trans Delta 8 THC is an isomer, a minor active compound in cannabis occurring only in trace amounts, if at all, and varied from, although it's more stable than Delta 9, it persists in old material, and it's been found in the burial tomb dating back from the 4th century. And this may have been one of the, I didn't look at this reference specifically, it may have been the one that Ethan Russo might have had looked at. I don't remember which one this is, but you're looking at a 99.9 to 0.1 or 98.6 to 1.2. And again, the same way that you would have seen the CBN in the old product too, probably very close. It still talks about the fact that it is a degradation product that can be seen through the product, or maybe even back in the early years of land-raised products that it was in a higher percentage of the THC cannabis plants. When you're looking at each one of those, it is looked through a shift, and that compound is much more stable. So as an organic chemist or as a chemist in itself, you can see that there's a strain that you can strain in the bond that's twisted a little bit, and that's why it prefers to be over on the other side of the ring. So we look at that, and there's a number of different synthetic modes. There's been patents that have been put out as far as how you translate over to Delta 8 and transitioning over to those as well back into the 2000s. So Jan, again, looks at this as saying, well, it's a natural compound as much as CBN. And you can see that it was even seen back in the 4th century, for goodness sakes, and takes those parts as being a great advocate for the fact that it's a natural compound that coming from hemp or coming from any type of cannabis. Ian, on the other side, believes that this is just another way of a transition from Delta 9. The CBD can, through isomerization, translate, close that lower ring and turn into THC. And from the THC, you can go to Delta 8, but you can also go directly from CBD, from the hemp plant, in a natural fashion to be able to get to Delta 8. It's a severe natural, but it still can, it is a pathway. So when you look at the different molecules, and from the same expert dependence on the WHO study, and on the WHO study looking at the drug dependence, another part of this program, there are other molecules of THC. There's 6A. Depending on how you do the naming, you can see over on the right-hand side that if you really want to go into the real name of these compounds, then that's going to be a mouthful. So there's no one that's going to say 6AR, 10AR-6A7, 10A tetrahydro 669 trimethyl 3-pentyl 6H dibenzo DB pyron 1-all. And so they know it's an alcohol, and Delta 8 just slips off the tongue a little easier. But when you look at these all have, they've been looking at some of the general pharmacology, and you can see on the 10.4, looking at some of that general pharmacology allows you to know some of the work that was done up until the time of when that World Health Organization committee report was published. Another way to look at this is cannabis and synthetic cannabinoids. So early on, even with the cannabinoids, being able to make something that would be even more amenable to the body for a specific therapeutic purpose. That's what they do in natural compounds all over the place, whether you're making aspirin or you're making other molecules that come from a compound. You typically will add other groups like nitrogens or hydrogens or nitrogen rings to make the body more amenable to that, to a site that you want it to go through. So they talk about classical, similar structures of THC, amino alkylodiols, indenols going back through, non-classical. So you have, cyclohexane phenols. So there's a lot of different molecules that can be made from these that make it more amenable, but also looking at the active sites. So when you're looking at the active part of the molecule, even within that, right, we'll look at some of the parts that influence the activity of these compounds and where they were made. So for example, the one on the left-hand side is delta 9, and the R group is a friend that goes along with it. So RN5H11 is what we call delta 9 THC, because it has that five-membered chain of carbons going down the right-hand side. You can change that chain and bring more amenability. I believe Dr. Alexandros Makarianos out of BU has done a lot of work on this. Other people certainly have done some other work. That's just one that comes to mind off the hand. I'm sorry that I named only one, but you can look up the literature and you can see that those formulas are still in place. You can look at the one on the right-hand side and see other work that has been done on what we call delta 8. And you can see again the five-member chain is your delta 8, but then adding on other groups and looking at those capabilities and those more bioavailability as the chain length gets longer and as you change things. So what kind of effects do we have out there, and if people really looked at delta 8 versus delta 9? And these are just 3 papers that I had pulled up for you to take a bite on. But again, it's the psychoactive plant cannabinoid delta 9 and delta 8, and looking at in mice and some of the work that was done there. You can look at the one in the middle, enhanced solubility, stability, and looking at the use of cyclodextrins with delta 8. So you're putting them into something that makes it more amenable. Delta 8 is easily as insoluble. It's a lipid, and so it's not going to go into water. It's not going to go into the body easily. And so you have to somehow get it into a presence. This one is looking at the eyes and the octal work that was done. Again, this is done by the group. Again, you see Dr. Asoli's great work there. And then you look at Alexandros Makarianos's work that I also always look in tune to. I visited the lab a couple of times. He does some fabulous work. He has, a great group looking at some of the work, other things with NMR and solid state NMR and preparatory, but also he's also made the deuterated compounds, so synthesized ones with deuterium, and looking at the deuterated compounds so that you can follow what happens with that compound as it enters the body. So typically you have tritium or you have deuterium that you're using to replace a hydrogen, and so therefore you can track what happens in the body. This is a great work that talks about some of that, but also within that work it allows you to follow where things are going, so you would know what happens with delta 8 versus delta 9 versus delta 10, 10A, 6A. This is one paper that I looked at that I thought intriguing, and it was looking for suspects in forensics, and it's a disturbing paper in the fact that it was post mortem, as you can see there. And what it looked at was it was looking at the suspicion of these people who died, and they were looking at why did they die and what had they taken before they died. And one of the postulations was, well, it must have been a delta 8 thing. They must have taken something that was bad. It must have been delta 9 and what they did is and that's why I always head towards modern tools. And in this paper, they look at the second page here, and that is metabolism of delta 9 and delta 8 with respect to structure of unknown compound. It's not as though I have to read to you like Goodnight Moon, but I am. And so with respect of the structure of unknown compounds from equal fragmentation patterns and similar chromatographic behavior, it's hypothesized that the unknown compound may be isomeric to the position of a double bond of the cannabinoid ring A. Delta 8 is such an isomer of delta 9, exhibiting its double bond between C9 and C8 in the cyclohexyl ring. For that to show, it says for delta 8, similar psychotropic profile was shown, but the concentration of the material is very low in comparison to delta 9. When it's looking at this, it was saying, well, is this possible that this was one of the reasons? And when you look at the delta 8 THCA artifacts of delta 9 and delta 9 THCA, I cited the three references here, 12 through 14, one from Turner, Osoli, Shulam, and then I forget the original, has Dazzle, going back through looking at, the Journal of Natural Products and looking at science magazines and looking at Journal of Organic Chemistry to see where these are. And as they explored it further, they looked at the liquid chromatography, the ability of where these compounds elute out of a chromatographic column. And you can see the delta 9 THC at 3.95, the 11 hydroxy, which would be in the liver at 3.0, and the THC carboxylic acid. So when you look at those at 3.05, you can see that there's a difference between those compounds that they were looking for that showed the post-mortem, and you see the delta 8 it's not a whole lot different. It's 3.97, 3.02, and it comes out a little earlier as the carboxylic acid. But then you're looking at the serum sample, and you can see the serum sample is more like THC, but then you're not exactly sure. And I think that what happens on here, you're showing that the behavior of the metabolites and the forensic serum that was taken from the user. But when you look at the mass spectrometry, you see from the mass spectrometry that it certainly is not the delta 8 or delta 9, because you're at 299, 299, and then you're looking at 302. So there has to be something else that was within that, and then also looking for what the different compounds would be. So within this allows you to have forensic science of having evidence based on sophisticated modern tools. And that's the challenge of what you're having for delta 8 versus delta 9 is even within this serum and looking at these, you can see that there's something very interesting between the two compounds. So you see the mass spectrum of the delta 9 carboxylic acid, the delta 8, and the isomer. So each one is has a collision energy of 24 volts. So that's important to be able to have those unique and looking at the fragmentation patterns. But you can see the fragmentation patterns of delta 9 and the delta 8 are very similar. So when you have that, you're able to know very quickly that they're similar, but also there's an abundance of the different ones on delta 8 versus delta 9, but the numbers are still the same. Probably the one that's most different in this case is the 147 peak that you can see is not highlighted in the top chromatogram with the delta 9 versus the delta 8. So it is breaking down. The 165 versus 161 shows you that it will have a different fragmentation breakdown. But to be able to do that, you're looking at the mass spectrum of gas chromatography, not liquid chromatography. So when you look at the delta 8 UV spectra, and this is taken in line during a chromatographic run, you can see that the delta 8 has a couple lambda maxes. That's your highest intensity peak. So you have a 208, but you also have something around 230, and you see something out around 280. And that's why people do different UV spectra. They take 3 different wavelengths that they might look at. You look at delta 9, it's 209, hard to tell the difference. You can see that again, you got something around 230 in the shoulder, and then you have something around 280. If you overlay those two photodiode arrays, they're similar but not identical. That's one way to spell identical, probably not the one that's in Webster. I don't know which language that would be in, probably Oompa Loompa, very close to English. So if you can see the difference between the Delta 8 and Delta 9, you can see that there's not much of a difference. And so it'd be hard to distinguish those just by UV. The second part that you have is that you are able to distinguish them by looking at the separation. But again, it's 4.24 versus 4.3, very close in compounds. So you see the standards in a mixture. We find it hard to find, even back in the days, of finding standards that were pure, so you could actually, what was, totally pure. The degradation products of both of these fall apart pretty quickly. Let's look at electrospray positive. So now we're looking at the positive ions, so it's 314 plus 1, that brings you to 315. And even within those two, it would be hard to distinguish with this one with API. So, it's both of these look very similar. And when you look at those out of the sample, you can see that, again, even though they were separated by chromatographically, they tell you that it really is Delta 8 versus Delta 9, but how we didn't do some of the other ones with 10A and such. Another paper that I liked came out of, I believe it was Brazil. And from this paper, it looks at a couple of different things besides just the mass spectrometry and besides just the chromatographic separation, but also looking at ion mobility. And so with the ion mobility, we'll discuss that in a second, but typically what it does is it gives you another factor into the separation and into looking at the compounds. So even though they're the same molecular weight, they are going to be a little bit different. So if you look at that top peak there, figure, you're seeing a molecular weight of 314. There's your C21, H30, O2, and that's your minus Delta 9 trans. And the one on the right is minus Delta 9 cis. So when you look at that, you look at those two hydrogens that we talked about before, one going into the chromatogram, into the paper, and one coming out. They're opposite each other. So they're like this. And then the ones are cis. That means that they're on the same side of the molecule. And traditionally, you'll see very little of the cis. You see the next compound there is minus Delta 8 trans. And so you also have CBL, you have CBC, and you have CBD in those same configurations. When you look at the bottom one, you see the 358, and now you have the carboxylic acid group. So you have the CBDA, and you have CBCA, and you have Delta 9 acid A and B. So when you have the acid A and B, it's always been pontificated that, why would you have acid A and B? So THCAA puts the carboxylic acid group next to the hydroxyl group. So it's ortho to the hydroxyl group. When it's on the opposite side, it's para, so it's opposite. And so the carboxylic acid group being down by that 5-chain carbon, that's THCAB. So you don't see much of that. Most of the time it's hidden away, but it's got to be in some portion of the compound. And then you also see Delta 8 trans with the carboxylic acid group already in place. So to say that the CBDA only goes through CBDA, then the CBD. So there's a number of different pathways, and it shows that it's possible to have the acidic form. So when you're doing this type of work, it really brings it into time of flight, mass spectrometry, and then you have a traveling wave, which I won't get into, but it does give you a certain greater differentiation of the solutions. So think of it, typically we think of it like a piece of paper that is flat, and you have another piece of paper that is folded, and I have no idea if I'm on camera or not, and then you drop them and they drop at a different rate. And that's really what you're doing here. So when you see the diagram below, they have the same retention time, but they have a drift rate that's different. So even though they are co-eluting through just direct infusion, you can see that you can still get a separation. You can see from there of those compounds, you see THCA, CBDA, and delta 8 THCA, C5. So each one of these compounds drifts a little bit different, which tells you that these two compounds are different, but not very much. These two chromatograms with retention time, the one on the left-hand side is, I believe, electrospray positive. Yes, because that would be all the positive ions. And then you see on the right-hand side, the ones with negative. And the A, B, and C, A is a extract of hashish. They call it hashish. So that's an extract from a plant. The B is from the flower, and C is from the leaf. So being able to look at where within the compounds within the plant these come from. So when you see D, E, and F, those are the same thing respectively. It's just that they're negative ion, and you can see that there's a far more sensitivity on the negative ion. There's a lot more peaks. Most peaks wins. And so when you're seeing each one of those, you can see how each one, even though it goes from 345.2040 to 357.2030, I mean, those are not very large numbers, especially as you start to move towards the middle part, but you're seeing, again, some significant difference in where the plants are and what comes out in the extraction. When I'm looking for different parts of how do I actually analyze this, so part of your concern about delta 8 is not only about the compound itself, but being able to have instrumentation that will allow you to know exactly what's in that compound, because you can see that because they're so close and they're so within the double bond, separating them is a challenge. And separating them means that you have to have analytical equipment and analytical and analysts that understand how to use that equipment to be able to get you the best answer possible, or you're going to merge them between them. When I first saw the work of delta 8, it was in 2014. Early 2014, being in a laboratory, we were seeing that there was a small shoulder on the back side, much like we saw in that UV, but just the tiniest amount of a shoulder that led us to think that there was something co-eluting. And when we went to change the chromatographic conditions, that's when we first saw delta 8. Nobody in the room was jumping all over delta 8 because it was 4 years before the Farm Bill. And so when you looked at these two things, you can see on the left-hand side the THC type cannabinoids. I mean, I really do read everything that Arno writes, and this is another great paper by Arno and et al. That goes through how to do the analysis, what's essential for a great analysis. So THC type cannabinoids and CBD type cannabinoids allows you to see where the different groups can be and where the double bonds are, and being able to highlight these two, but understanding that you need to separate them. So when you're looking at the regulatory sampling of industrial hemp and plant using UPLC, MS, so ultra performance liquid chromatography allows you to have a very significant increase in selectivity. Remembering that selectivity is also a part of not just individual components, but looking at things that are underneath the component. And so not only being able to see what's separating one from the other, but also being able to understand that you are going to have some components that are co-eluting. In this case, you see the standards up on the top part with a MRM. MRM means I'm just looking at one ion and trying to look at what is happening with those ions. You can see that on the one below, it is a sample. And so you can see how you can get great resolution from those samples and being able to know exactly where you are and what you're doing. But when you're moving towards Delta 8 and looking for these, to make sure that what you have is what you think you have. Sometimes you're seeing in the analytical laboratory that they're calling it Delta 8 because they don't have the separation power, and there's been a movement. The other part that we saw from that ion mobility experiment was that the compounds are very, very similar. So you can actually separate multiple compounds from each other, even though they look like they're one THC, they could be multiple, Delta 9 THC, they can be multiple compounds. Very important. So this is a nice paper that is one to look at. Well, how do I separate these two? Well, one of the ways that I did with Eric Kalka up in Vermont, Hardwick, Vermont. If you want to look where Hardwick, Vermont is, it'll show you that you're not walking there today. And so when you see that, you're able to have the Delta 8 versus the Delta 9. And with supercritical fluid chromatography versus HPLC, high performance, liquid chromatography, or GC, you're seeing that you can separate these compounds significantly because it's really meant for those types of nonpolar compounds and does a great job separating them. When you're able to separate them this far apart, it also means that you're able to isolate them. Remember, one of the first slides we saw was isolating the compounds. Natural products, back to where we started. So whether you're doing the plant or you're doing extraction or concentration, you're really looking at the entire process. You're looking at all the way through of all the compounds that can be coming through, and even through the blue, the light blue one, all the way to the purple. So if you're looking for Delta 8 and looking for a reason for Delta 8 to be separated, you need to have it in a pure form, because currently there's a lot of different ways of synthesizing it, but synthesizing it through catalyst means metal, synthesizing it through Grignard reagents means metal, synthesizing it through different acids, Lewis acids and Lewis bases and such. You're having to use compounds that make sure that you have to have them out of your final formulation. And there's people that are doing this very well, and there's people that probably aren't doing it as well. And that's one of the considerations that you have to have as you're moving through with products that you're wanting to provide. What's your vendor, as well as if you are providing yourselves, making sure that you are having something that's really pure. So I do talk about this one as a joke, and so I put this up as a warning slide. This is meant to be a joke. There's nothing on the market. Please don't email me and ask me for one. And I call it the automated botanicals concentrator, as easy as ABC. And in this fact, you're pulling out what you want, and you just ask it to give you what you want, and that's all you're going to get, and leave everything behind. Whether it's the cannabinoids, the acidics, or the neutrals, whether it's the terpenes or the mono, or the oxygenated, the sesquiterpenes, the triterpenes, it doesn't mean you just set it and forget it, and off you go. And so that's all you get. And so within that, that's not happening. Currently, it's not happening. And the second part that I talk about is the best concentration processes for natural products. In this case, botanical materials integrity maintained to assure the concentration of the desired components in their natural form. And as you're moving towards the Farm Bill and the hemp, that's what you're trying to drive towards. You're driving towards the compounds in their natural form, and being able to make sure that you can have those same things. And Delta 8 is one of those molecules, as well as CBN. I would also, and I'll say, well, what's the next molecule that's going to come up that we believe also has effectiveness? And that brings me to effective concentration with efficacy, efficiency, and economics within redefined boundaries. Because it's not predefined anymore, it seems to be redefined. And so as you're going through, making sure that you have those components in place, and the safety of everyone involved through the process, certainly all the way through the concentration, and enhancing the amount of Delta 8 that you have through accelerated degradation. So you're really doing accelerated degradation of a product to provide you with a component that's from there. You're doing accelerated degradation of wine. You're doing accelerated degradation of whiskey. You're doing accelerated degradation of cheese. Each one of these allows you to have a product that you want that the plant didn't originally make. You're just doing accelerated degradation. And then testing with modern technology. This is critical for as you're finding compounds that are more similar to each other, especially delta 8, delta 9, and especially when you start to move towards the enantiomers or you move towards mirror images. Those are going to be the next ones that allow you to drive through that and being able to have a vendor that allows you to give those answers. So what's the future? That's a good question. And I think that the answer is going to be driven towards the boundaries of where you're working within the process. And the more research that you're able to do, looking at the activity of the CB1 and CB2 sites as you're moving through the process. But everyone, I won't say everyone, but many people focus only on what's happening in the brain. And that is important, but at the same time, what other things can happen on the skin? What other things can happen within the eye for, ocular and glaucoma and other places where you want the molecule to go? All those things become important as you look at the future. For example, I think last year, it was a year ago, almost a year ago, that CNE News, Chemical and Engineering News, put out an article on the growing pains. And many of the growing pains that were cited in that argument are the growing pains that we are talking about today. And the plant over on the left-hand side is hemp. And the fact that it's hemp and it looks like marijuana is a real deterrent for how do you regulate a market that other people that don't have your ethical or your medical or your desire for making a medicine. Some people, rob banks. So when you're looking at that, that's a possibility. I'm still going into bank. It amazes me that I'm putting a mask in and I'm going into a bank and asking for money. Didn't work that well in the 1870s. So the other part that I see is, the collaboration. Andy Bruning does some great compound interest infographics. I mean, he is really good at these, and it's worth a look at just his website. But what is a cannabidiol, and how does it work? I mean, where's the efficacy and the regulations and medicinals and supplements? These are things that we need for helping people, as I started off way in the beginning with the first slide of asking people what they know about CBD. Having things that are understandable for not only the PhDs, but also for the people on the street making decisions about the products that they're purchasing in gas stations in South Carolina. So we're back to Ian and Jan, and where's the middle ground? And are you involved in the science? And if you're not, then probably a good time to get involved in the science and finding some of the academic places that are working on it, or the ones outside the United States, because that's where a lot of the work is being done, and being able to understand where the process is going. And with that, be happy to take any questions.
Okay, well, thank you very much, Mr. Mckay. So, oops, let me turn that off. We do have quite a few. So we are going to start with what I think will be a couple easier ones first. First, yeah, I don't want to stress you out. So first of all, so is Delta 8 considered synthetic?
You can, well, going back to the slide with the CNE News, and that is the plant makes it, and it's a degradation plant as much as CBN. But just like Delta 9 or any of the other isomers, it can be made synthetically. But that's not an overall yes/no question. That's a question that says, that's an answer to a question that says you can make it both ways. And for example, Dr. Macrionis is, I believe he has the patents on most of these deuterated compounds to be able to know where they are. So the quick answer is, it depends. If the plant makes it, it's not synthetic. If you're making it from starting material that's not from the plant in a petri dish, not a petri dish, a beaker, then it is synthetic.
Got it. Okay. Is Delta 8 found in all cannabis flowers?
The slide that I spoke of with Dr. Asoli and all the work that he has done, according to his paper, he found it in the flower. And also from the WHO, the World Health Organization, cited references where the material was found in the flower.
right. What extraction techniques are used to extract delta 8?
You can, so first of all, it's solvent dependent. So I will move towards a indifference to the questioner, and that is I would move towards concentration. So concentration is taking all of my M&Ms in a big pack of M&Ms, and from there I'm deciding that I'm only going to want to have the red, the blue, and the green. And so therefore I set up a criteria that I'm wanting to collect those. So every concentration, that's a concentration. So concentration is split up into two things. One is the use of solvents, that's an extraction. And then you have a use of no solvents, and that's a separation. So you can concentrate the amount of material by doing a by gathering all the trichomes. And so you can do that by having them very cold and then dropping off the trichomes, kind of like apples off a tree. And then from there you can concentrate them through ethanol or use them in that phase. So you can't, there's not a mode for extracting delta 8. It becomes one of the components that's in an extraction. So there is no, I have no preference on that. It's more of the formulation centric. What are you trying to make? And then you back up to how you can get those processes in place to maximize your amount of delta 8.
Got it. Okay, we're moving on to more. Let's see here. What endocannabinoid receptors does delta 8 and 9 target?
So the work that I read, and remembering I'm not a lawyer, nor am I a medical doctor, and I will cite that there's thousands of people alive today because I'm not a medical doctor. And so the work I'd read was moving it towards the CB1 site. And so, but I would share with the user that I would go to semanticscholar.org, and from there you'll get a significant number of the PubMed articles that would be cited on that. So I would bring the user to that and then have them read the articles, but the ones I'd read were focused on the CB1 site.
Got it. Okay, so it looks like we have 1, 2, 3 more. So the next one is, here is the current challenge for D8 as I see it. 90+% purity synthesis, scalable, repeatable. I don't know anyone who has truly dialed it in. Do you have thoughts about this? And compliant, repeatable, scalable, compliant.
I think I have more nightmares than I have. The number one thing, so of the people that I'm believing are most successful in this process are using separation technology that allows them to have the differentiation based on the chemical process itself. So the number one way to do this as just the accumulation of the delta 8 isomers and the accumulation of the delta 9 isomers is to use supercritical fluid chromatography. That's the easiest way because it's a non-polar solvent. There's other ways to do it, of course, with liquid. And then you also have the next media that has to bring you there is chiral columns. So when you're looking at medicines such as the one with the butterfly that's advertised, you go to sleep. So that's not only an isomer, but it's also a chiral isomer. So remembering the hydrogens that were coming out and the hydrogens that were going in, that's important to the body. So back in the 50s, there was a drug that caused enormous birth defects, and it was based on a very small amount of an isomer that accumulated poison in the woman's brain and then passed over through the umbilical cord. And it was horrific, and they had to take it off the market. But that's the reason why the United States look at antiumeric excess. And there was a paper that showed the antiumeric excess between delta 8 and delta 9, showing that even in delta 9, there was a little bit of the cis in there. Well, does that mean the cis is bad or good? It only needs to be studied to see what its long-term effect is. When you had the same thing with delta 8, then you're also looking at those other isomers. So the isomers that come from CBD because that ring closure has not taken place. So you've got an oxygen that's open, so there's a couple ways that it could spin around and close, and those could give you different isomers of the delta 8, of the delta 9 moving to a delta 8 or moving directly to a delta 8 from that. And so those are the things that are possible. You also have a study that was done on CBD that showed that CBD didn't around that one carbon, it didn't spin around and around. It spun, where am I? Where's my finger? There. It would spin like a ratchet, click, 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 because of the stereochemistry. And if it, where's my finger? So if I, there we go. So if I took that and I stopped at this click, then I might make one isomer. If I stop at this click, I might make another isomer. So those are the things that are possible in organic synthesis that could, even through natural circumstances with the CBD, cause it. So I think that's a long-winded answer to it depends.
Got it.
But you have to have the ability of knowing that the manufacturer is providing all those and understands the criteria that they're making this product in based on organic chemistry.
Okay. Next question. What stage of development is CBL-C found?
I don't know. I would again go to the semanticsscholar.org, but I wasn't prepared for that question.
Well, honest answer. So, yeah. Okay, we're going to move on. So, let's see. Next question, actually, and then one more came in. Do we yet understand why the rearrangement of the 8-position double bond can elicit such a different binding affinity to the cannabinoid receptor to create less of a psychoactive effect? How does this small change impact the neuropharmacology?
Well, this would be right up there with a law case from the UK, and so it goes outside of my expertise. It really does go to another researcher that would know the KI and how it's falling onto that, where am I? Falling onto that protein, and from that protein, what other proteins it's making based on that, and the ratio of those proteins. Because we talk about anti-inflammatory, and we talk about cognizant, and we talk about dopamine, and we talk about other things, but the ratio of those is the most important things. And so I would send that question over to Dr. Mckay, who is one of my go-to guys, or I would send it over to Dr. Ethan Russo, another one of my go-to guys, or a fellow up in Vermont. I would send it over to one of the medical doctors that's more competent, or the people that work on that better. Quick answers, okay. I don't know. Longer answer is the one I just gave.
Okay. Last question we have here. So if anyone else has any questions, please put them in the Q&A now, because we're on our last one. Thank you. Okay. When orally ingesting delta-8 THC, is it metabolized in the same way as delta-9? Would it convert to 11-OH THC, or is there a separate isomer specific to delta 8?
What I showed in the forensic article is what they should look at. And the quick answer is yes. And the longer answer is to get a hold of that paper, and you can see it by blowing up the screen when you get to that paper. And that covered it really well. There is a delta 8 and a delta 9 different mechanism path through the liver. But it's cited in that paper, and it's better to read that paper.
Okay, so couple of things real quick. Could you audibly tell people, John, how to find you? Because some people aren't going, they're just listening audibly. So can you tell them the best way to contact you, first of all?
Oh, they missed the best portion of me on screen. I feel so badly.
Actually, I had you blacked out the whole time so we wouldn't make people suffer.
Oh, that's probably a good idea. So it's J Mckay, Mackay, at synergistictechresearch.com.
Awesome. And the phone number?
And the phone number 774-462-8363.
Awesome. Okay, last thing. We've had questions of people asking if they can, oh, and then we have one more question. Okay, we've had people asking if I can make this presentation available to the people who registered for the webinar. Will we be doing that, or would they have to contact you?
No, I'm assuming you're doing that.
Okay.
Right?
Oh, okay. Okay, I'll do it. So yes, you guys will receive, you're welcome, John. So you guys will receive the presentation via email. Give us usually 24 to 48 hours to get that in your email box. Or your
I was just very happy with the fact that I was able to put the presentation onto the screen.
This is true.
Successfully. I was happy with that.
This is true.
I was not the kid they chose in 7th grade to go up and help them with the overhead projector.
I believe that. Yeah, it's you guys, I love John, but I'll tell you, sometimes there's a little technology just challenged, but we work through it. Okay, one more question we have here. Okay. Is it possible to get delta 8 without the use of solvents?
So when the quick answer is yes, because if you're willing to take some starting material and have it exposed to light, I don't know that that's the fastest and greatest kinetic way to get there. And you also can do it through heat. So now you've got heat and light. We're actually using the energy for the other way is to heat and light. That's not the fastest way either, but that is possible. I mean, you could take live resin and move it over, I suppose. And I haven't done it. It's and you can take solvent that has a higher that goes away, like CO2 or some other solvent that allows you to go through. But those are ways that you could do it.
Interesting. Okay. And then someone just commented that they saw a brick of D8 keef recently, well, prominently D8. That's interesting. Thoughts on that?
No.
Okay. All right, you guys. Well, I think that is it. We have come to the end of the questions. And once again, my dear Dr. John Mckay, thank you for your time and joining us. You are just a diamond in the rough, and I appreciate you and adore you so very much. So,
well, thank you so much for the opportunity to be able to share, and be sure and look up those references. That's the biggest thing I have for people is to be aware versus Ian and Jan. They just tend to make up stuff, but I think that studying it would be great. I mean, Ian and Jan really should take John's advice.
I agree. Okay, you guys, everyone is giving you big thank yous, John. And they're saying
Welcome.
it's the best webinar that they've been to all year. And well, of course, you know,
It's early in the year. It's early in
right.
the year.
But
Yeah.
everyone
Thank you.
is saying thank you, and you were so great. And
All
thank
right.
you for your time. So thank you,
All right.
everyone, for
Thank you.
joining us. And
All right.
we'll be back with more webinars in the future. Have a great day.
Bye.